Hello, this is Mr. Vetro. Today's lesson is on quantifying predictability. Yesterday you did other types of regressions. So I'm just going to read the top of this lesson paragraph with you and then we'll get started for today. Okay, very simple lesson today. In the last few lessons, we have worked with generating lines and curves of best fit for bivariate data sets. In every circumstance, though, the data did not fall on a straight line or on a perfect curve. We have never answered the question of how well, specifically, a linear model does in predicting the correlation between the two variables. All right. Your teacher will explain how to ensure that your calculator has its R value on. Since this varies by graphing calculator, write down the procedure below if necessary. Okay. So today we're going to talk about something. We're going to talk about something called the correlation coefficient. You're going to see those words today, correlation coefficient. And what that refers to is this R value that they're talking about in exercise 1. So whenever they talk about the correlation coefficient, they're talking about the R value, all right? And the R value is a way of predicting how well a linear model, specifically a linear model, correlates, all right? Is good at correlating the relationship, all right? So when we're talking about correlation coefficient, we're really talking about linear models only and the R value. And we're seeing how that R value that is good at predicting the correlation. All right, how good the R value, how good the correlation is. All right, so this is what we got to do. So everyone turn your calculators on, okay? And I want everyone to go to their mode. Mode is right next to the second key. It says second is mode up here, mode quit, hit mode. Now when you hit mode, this screen comes up. You might have radian highlighted instead of degree. It doesn't really matter for you right now. That will matter when you're in Algebra 2, all right, or even in geometry a little bit. So what's important here is we want to scroll all the way down, sorry, to stat diagnostics. See how mine is off? You want to go to on and you want to press enter. You want to put your stat diagnostics on. When your stat diagnostics is on, you'll be able to see the R value now. I'll show you what I mean in a second. All right. So I'm going to get out of here for a second. And we're going to go to the next exercise. Exercise 2. It says, in the following exercises, 4 data sets with equal X values are given to illustrate different types of positive correlations. For each, enter the data, observe the scatter plot, and record the R value, known as the correlation coefficient, for a linear fit to the nearest thousandth. Okay. Well, we're going to enter this data into lists. So this is going to be like your L1, L2. Now, you're going to have to do that for all of these. Just hear me out, so I'm going to help you. I'm going to help you with the first one. You can do the rest. Notice your L1s are the same in all of them, so that's nice. You're not going to have to retype those in. But your L2s change, so you're going to have to do this 4 times, okay? But at least your X values stay the same. Anyway, so we're going to enter these into our list, and what we're going to do is we're not going to look at the scatter plot, all right? We're going to record the R value by looking at the linear equation. So what I mean by that is take a moment and type these numbers for exercise A into your calculator, into your lists. It should look like this. Okay? Pause the video. Make sure you have that. Once you have that, we're going to get a linear equation for this. We're going to go to stat. We're going to go to calc. And we're going to do option 4, which is linear regression. I'm going to press enter. And I'm just going to go all the way down to the bottom and hit calculate. And now notice I have an R value on the bottom. Don't worry about R squared, but I have an R value. They say to round that to the nearest thousandth. So it's 999. My R value here is 0.999. We'll talk about what that means in a little bit. Okay. Now, what I want you to do now is do the same thing for letter B, C, and D and record the R value. To pause the video, you might want to take a minute and do it on your own, okay? But before we do that, what does 0.999 mean? It means it's a very good fit. It means a linear model is a very good fit. I want you to do it for B, C, and D, all right? So pause the video. I'm just going to continue right now. For letter B, you should get R equals 0.930, which means it's an okay fit. Not as good as letter A. Letter C, you get R is equal to 0.776, which is a poor fit. And if you looked at the scatter plot for that data, it would be very scattered. If you looked at the scatter plot for letter A, it'd be in a linear, it'd be more closer to a line. In letter B, it'd be close to a line. It'd be like the points would be like very close. In letter B, it'd be a little close, but not exactly as letter A. All right. B, they'd be scattered all over the place. So D, if you looked at it, you get R equals 0.133. Sorry, which is almost no fit at all. So if you were to make a scatter plot for A, B, C, and D, letter A, based on its correlation coefficient, means the points are going to be very close to a straight line. B is kind of close. C, a little scattered apart, but going in a positive direction. D, they're all over the place. All right. All right. D, how does the correlation coefficient quantify the fit of a positive correlation? Well, if you're noticing the trend here, the better the linear fit, the closer the value is to 1. 1 is the key number here. The closer to 1, the better the fit. All right? The poorer the fit, the closer the value is to 0. Okay, just like in letter D here. All right, exercise 3. The following data set is that of two variables that have a negative correlation. Enter the data, produce the scatter plot, and record the R value. How is the negative correlation reflected in the R value? Well, enter these numbers into a list, pause the video. This is your L1, this is your L2. Get the linear equation up, and then look at the correlation coefficient. You should get R is equal to negative 0.945. So it has a negative value, and it's close to negative 1 because it is a good fit. All right? This is a very good fit. If you would make this scatter plot, you would see that the points kind of go like that, all right? Whereas a negative, it's not exactly a straight line, but it's close to it in a negative direction, okay? So this is also a strong fit. It's just negative, all right? It's still good. It's close to negative 1. How is a negative correlation reflected in R value? It's close to negative 1. That's important. All right, let's keep going. Given the scatter plot shown below, which of the R values would most likely represent the correlation between the two variables? Well, it can't be 1, because if it was 1, I'm meaning choice 3, it'd be a perfect line. 1 means it'd be a straight line. And it can't be negative, right? Because it's all going in a positive direction. So it's either 0.88 or 0.288, and closer to 1 means it's a stronger than closer to 0. So I would say it's choice 1, right? That's the best pick here. All right. Exercise 5. Which of the following would have a correlation closest to negative 1? Well, this is going up, so it can't be that. This has no correlation, really. This is going down, and this is going down, but closest to negative 1 would be the straightest line. So choice 4. All right, exercise 6. There are two primary types of crude oil sold in the world, West Texas Intermediate and Brent crude. Each is priced differently on a daily basis, and each has a correlation with the average price per gallon for unleaded gasoline. The two linear regression models, along with their R values, are shown below. Give a prediction for the price per gallon of unleaded gasoline Y on a day when the price for WTI is $103 and the price for Brent is $109. Which model did you choose and why? Okay. Well, if you look at this, if you were to plug in $109, okay, in for Brent, so basically I'm doing 0.028109 plus 0.71, all right, you get 3.762 which means $3.76 per gallon. All right. So either way, you should, and you could do the same thing with WTI crude, but it says which model would you pick based on the lesson we just did. Look at the R values, even though they're very close. All right, which one should you pick? Brent crude. All right, the Brent crude model should be used to predict the price of gasoline because its R value is closer to 1 than that for WTI crude. All right, so that's basically the lesson, guys. Very simple. Correlation coefficient, R value. You need to get it on your calculator. Okay. If you have an older calculator, you might have to go through your catalog, which is second zero, and access it from there. Okay. All right, guys. Work on the homework, and I will be with you tomorrow. Have a great day.